Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today I want to discuss about the question bank. So in this question bank, the topic is principal stresses and strains. So how to attempt the given question in examination, so related to the principal stresses and strains. Already we have discussed about the principal stresses and strains and derived the equations, and also we have done some problems related to this principal stresses and strains. So now in this session, so particularly we will see some important questions related to the principal stresses and strains and the solution also. At the end of the course, the student should be able to demonstrate the principal stresses, principal planes, and torsional stresses acting on any arbitrary plane within a structure using analytical and Mohr circle methods. So that the students, after completion of this module, already they have completed this theory and problems. You are familiar with this premier principal stresses and strains. Once again, I apply equations for this given question. The question number 1, the principal stresses and strains. What he has given. A tie bar is subjected to a uniform tensile stress of 100 Newton per mm square. Find the intensity of normal stress, shear stress, and resultant stress on a plane, the normal to which is inclined 30 degrees to the axis of the bar. So also estimate the maximum shear stress in the bar. So a tie bar is subjected to uniform tensile stress of 100 Newton per mm square. Find the intensity of normal stress and shear stress and resultant stress he has asked. The inclination, which is inclined 30 degrees to the axis of the bar. So also estimate the maximum shear stress in the bar. So the principal stress and strains. The solution given here shown. The given bar is the tie bar subjected to tensile load. The inclination plane is shown here PQ, and the angle of inclination 30 degrees. So normal stress, tensile stress you should calculate. So the normal stress is equal to sigma into cos square theta. So sigma n is equal to 100, already given the stress, the 100 Newton per mm square, the uniform tensile stress. Newton per mm square. So 100 substitute here, and then cos square, the theta is 30 degrees. So the normal stress is obtained 75 Newton per mm square. So the sigma T, the tensile stress, shear stress acting tangentially, the tangential stress, sigma by 2 into sin 2 theta. So calculate, substitute the sigma value here, and then theta value, you will get 43.3 Newton per mm square. So the final here, first you should apply the normal stress equation. So this is important, sigma into cos square theta. We don't know this equation, you can't calculate this problem. The normal stresses obtained 75 Newton per mm square, and tangential stress obtained 43.3 Newton per mm square. Now the resultant stress, the resultant stress is equal to square root of sigma n square plus sigma t square. It's already shown here. So the obtained values here substitute 75 square plus 43.3 square. So we will get 86.6 Newton per mm square. The maximum stress sigma by 2 at 45 degrees angle. The sigma t maximum is 100 by 2, that is 50 Newton per mm square. So this is the solution for given question. So intensity of normal stress we have calculated, and shear stress also we have calculated, and the resultant stress also we have seen. Now next question number 2. A tension member is formed by connecting with glue two wooden sclantings, each 100 by 200 mm at their ends, which are cut at an angle of 60 degrees. So the member is subjected to a pull P. Calculate the safe value of P. If the permissible normal and shear stress in the glue are 2 Newton per mm square and 1 Newton per mm square respectively. So tension member is formed by connecting with glue two wooden sclantings. Each dimensions are given 100 by 200. So the member is subject to a pull up load P. So calculate here safe value P. If the permissible normal and shear stress also given, so no need to calculate. In previous problem we have calculated. So here shown two woodens are jointed with glue, and then the angle is 60 degrees to the horizontal, or 30 degrees to the horizontal, and vertical 60 degrees. So 100 by 200 dimensions given. The question number 2 solution here shown. The area calculate first. The area is 100 by 200. So we will get 20,000 mm square. The angle of cut with horizontal 60 degrees. The angle of cut with the vertical cut 60 minus this 60 minus 90 minus 60, 30 degrees. So now the complete solution shown here, the sigma n given, normal stress and shear stress also given. So sigma n is equal to sigma into cos square theta, and sigma is sigma n into secant square theta. That is 2 into secant square theta, 30 degrees. So sigma is equal to sigma n by cos square theta. So that you can write sigma n into secant square theta. So theta value substitute here, you will get sigma value. And then the tangential stress, that is shear stress, calculate sigma by 2 sin 2 theta. So sigma is equal to 2 sigma t by sine 2 theta is equal to 2 into 1 divided by sine 60. So we will get 2.309 Newton per mm square. So the safe stress sigma will be lesser of two values. So sigma is 2.309 Newton per mm square. So here sigma value we got 2.309 and 2.6697. So the safe stress will be lesser of the above values, two values. Now the P is equal to find out load stress into A. Already you know stress is equal to load per area. So next question number 3. The next question number 2 solution is completed. So the mainly the two equations are important here, the same as first problem. But here two values you got, so take the lesser value, fix as a final safe stress. And question number 3, a rectangular bar of cross-sectional area, cross-sectional area given 10,000 mm square is subjected to an axial load of 20 kilonewtons. So determine the normal and shear stresses on a section which is inclined at an angle of 30 degrees with a normal section of the bar, normal cross section of the bar. So here stress is equal to load per area and sigma n is equal to sigma into cos square theta and theta value 30 degrees and sigma t is equal to sigma by 2 into sine 2 theta. So the theta value 30 and then calculate sine 2 theta. So we got 0.866 Newton per mm square. So direct formula substitution here. The problem question number 4. At a point in a strained material, the principal stresses are 100 megapascal tensile and 60 megapascal compressive. 100 and 60. So determine the normal stress, shear stress and resultant stress on a plane inclined at 50 degrees to the axis of major principal stress. Also determine the maximum shear stress at the point. This problem same as the previous two problems. But here the inclination angle is given 50 degrees to the axis of the major principal stress. So first we will see. So what are the major principal stresses and the minor principal stresses? So the major principal stress is sigma 1 is 100 megapascal and sigma 2 60 megapascal compressor. So normal stress and shear stress you need to calculate. So whenever taken this member like this, the sigma 1, sigma 1, sigma 2 and sigma 2. So this compressive nature 60 megapascal and 100 megapascal given tensile nature. So determine the normal stress shear stress and resultant stress on a plane inclined 50 degrees to the axis of the major principal stress. So also determine the maximum shear stress. So what are the shear stress here acting? As asked. So we will see the major principal stress sigma 1 is the given data. Sigma 2 minus 60 negative sign due to compressive stress. The angle of the inclined plane with the axis of major principal stress 50 degrees. So the angle of inclined plane with the axis of minor principal stress. So major axis and minor. What is the angle? Inclination angle with this minor. So that is 90 minus 50. So now calculate the normal stress. Normal stress. What is the formula normal stress? You know, sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 into cos 2 theta. So here 100 given sigma 1 and sigma 2 minus 60. So why? Because this compressive nature. So the given angle theta is 40. So already we have calculated the inclination, the angle of the inclined plane with the axis of minor principal stress. So that is theta is equal to 90 minus 50. So sigma 1 and sigma 2 major principal stress. Sigma 2 is minor principal stress. Clear? So you got final value 33.89 Newton per mm square. Sigma n. So using this equation, sigma t is equal to sigma 1 minus sigma 2 by 2 into sine 2 theta. This is the tangential shear stress formula. So already you know the sigma 1 value and sigma 2 substitute, and for 40 degrees also you will get the final value. So final value 160 by 2 into sine 80 degrees. So 80 sine 80. So what is the value of sine 80? Cos 80 already here calculated. So like this, you need to attempt the principal stresses and strains questions. So in this, the important thing is one is sigma n normal stress formulas, and then shear stress and the principal stresses equation. The principal stress equations already shown here, sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 into cos 2 theta. So we have discussed 4 problems related to question bank questions related to this principal stress and strains. So these are the references I have taken. So yes, Ramamurtha. Title of the book is Strength of Materials, and second author is R.K. Bansal, textbook of Strength of Material, Lakshmi Publications, and then R.S. Kurmi and Gupta, Strength of Material title, and then Achand and Co. publishers. So these are the references I have taken for this question bank PPT. Take any one textbook for further more clarification. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.